Hey guys, today we are going to go over some notes for interpreting heating and cooling curves. Okay, so if you would, go to thermochemistry, and on the right-hand side, we're going to be taking notes for interpreting curves. Okay, so make that full. Pull open this video as a split screen with this. Okay, so first off, heating and cooling curves. They're a graph of temperature against time, okay, for any specific element or compound. So this is just showing whether an element is either heating or cooling. Okay, so an example of this is like, what happens to the temperature of a block of ice when you put a Bunsen burner underneath it? What would the graph look like? So we're just trying to figure out what's actually happening to it. One thing we have to take into account during heating and cooling curves are the states of matter. So if we are going to be putting a block of ice under a Bunsen burner, we have to decide what are the states of matter that are involved in this. So we've got ice, we've got water, and we've got water vapor. If we are adding energy to the reaction, if we're adding energy to it, it's going to go from ice melting, okay, to water. That's going to evaporate into water vapor. So if we're adding energy to the system, it's called endothermic, because energy is going into it. Endo is into, energy is going into, it's entering. If we have water vapor and we are removing energy, we are cooling it down, it's going to go from water vapor to water, and then it's going to freeze into ice. Okay, so our states of matter are ice, water, and water vapor for each thing. Okay, our different phase changes are condensation going from water vapor to water, freezing going from water to ice, melting going from ice to water, and evaporating going from water to water vapor. Okay, if energy is entering, it's endothermic. If energy is exiting, it's exothermic. Exiting, exo. We'll come back to that in a bit. Okay, so the main point of this is a heating and cooling curve. Okay, so we have to understand, we have to read what's going on in these. So it says, in general, the temperature goes up as time goes on. So in a heating curve, temperature is going upward. Okay, we have this upward slope. Okay, the only time that it's not are during these plateaus. These plateaus, these horizontal flat parts, they represent phase changes. So whenever there's a flat part, it's changing between phases, such as melting or boiling. Okay, so whenever there's a change of state, there is a flat part. So for instance, in B and C, it's going between solid and a liquid. Okay, so that's melting right there. And between D and E, it's going between a liquid and a gas. That's going to be boiling. Okay, and you guys already know what these state changes are. Melting, going from ice to liquid. Okay, you know when things melt. And boiling, when you put it on a stove, liquid turning into gas. That's what boiling is. So during a phase change, the temperature stays the same. So when you're boiling water, it stays at 100 degrees Celsius the entire time that you are boiling it. It's just that these two states exist in various ratios. So that's what it means at the beginning of this state change, it's 100% solid. Throughout the state change, it's changing into liquid. Okay, so at different points, say in this middle, it's some mix between solid and liquid. Some part solid, part liquid. Once it gets to the end, it's 100% liquid. Okay, and this whole part is 100% liquid, this upward slope. Right here, we're right in between, or we're at 100% liquid again, and we start to mix between liquid and a gas. Right here, somewhere in the middle, we're about 50-50 liquid and gas. We're still changing our phases, getting here closer and closer to gas, and as we get to the end, it's 100% gas. Where this stays is gas. That's our gas state. Okay, so our plateaus, those are phase changes, whenever it's flat. And it's a mixture of the states. Okay, so temperature, all temperature really is it's a measure of the average kinetic energy. Okay, so what temperature is? It's just the measure of the kinetic energy of our particles. So any change in temperature is a change in kinetic energy. So whenever it's changing temperature, like right here, our upward slopes, okay, and we can see that because we have temperature on the side. So whenever it's going upward, we have a change in kinetic energy. That's delta KE. We have delta KE. Diagonal line segments show a change in temperature and therefore a change in kinetic energy. So all of these are a change in kinetic energy. Now, during our horizontal line segments, these are our flat ones, our plateaus, kinetic energy is being converted into potential energy. So during these, we have a change in potential energy. So whenever there's a phase change, there's a change in potential energy. Whenever there is a diagonal, that's a change in kinetic energy. Okay, so flats are potential. The diagonals are kinetic. Okay, so just a little bit on the differences between heating and cooling curves. Heating curves show that how the temperature changes as the system is heated up. Okay, so heating curves are when it's heated up. Heat is entering the system. They are endothermic. Okay, cooling curves show the temperature change as the system is cooled. We haven't seen a cooling curve yet. I'll show you that in just 1 minute. Cooling curves are exothermic because heat is leaving the system or exiting. So when heat is leaving it, it's exiting, they're exothermic. So it takes the same amount of time or the same amount of heat for ice to melt as it does for water to freeze. Okay? So freezing and melting, they occur at the same temperature. So if you're looking at one of our curves, let's go back up here. Freezing and melting both occur at the same temperature, right here. Okay, a liquid going to a solid is freezing. A solid going to a liquid is melting. They both occur at the same temperature. Now our last example, I just want to show you a cooling curve. All right, so in a cooling curve for this substance, we have the gas state. Okay, it condenses. It's our state change or a delta potential energy. It's delta kinetic energy. Here we have liquid. Okay, so when our states are at all of our diagonal parts, so solid, liquid, gas. Our plateaus are where we are changing state. Okay, so here we have freezing and condensing. That's where our delta PEs are as well. Our delta kinetic energy, our change in kinetic energy, are when we have a specific state. Okay, so let's go through a couple examples just to make sure we understand what's going on. It says what letter, but we're just going to say what point. Okay, so it says at what letter does the solid phase begin to increase in temperature? Okay, so we're trying to find our solid phase on here. Our solid phase is always going to be the lowest temperature one. So we have solid down here, liquid here, and gas up here. Gas is always the highest in temperature. Think of it like you're boiling things into gas. And solid is always the lowest temperature. Think of it as ice is very cold, gas is very hot, okay? And then our state changes in between, solid going into a liquid, that is going to be melting. And liquid going into a gas, that's going to be evaporating. Okay? So it says, at what letter does the solid phase begin to increase in temperature? So at this point, solid's going to be increasing in temperature because it's going at an upward slant. So that's where it's going to be increasing. It's down here. That's where it starts. Once it gets to this point, it's no longer increasing in temperature. It stays constant. Where does the potential energy change? So potential energy changes at any plateau. So whenever there's a phase change, so potential energy is going to be changing here, and potential energy is going to be changing here. So whenever there's temperature is constant and your phase is changing, that's when we have a change in potential energy. what is the boiling point? So at what point does our system start to boil? Okay, when does it start to turn from liquid into a gas? It's going to be right here. Okay, so at 120 degrees, okay, or right here is our boiling point. It's right when our system starts to boil. Okay, because it's starting to turn from a liquid into a gas. And what is the condensation point? When does it start to condense? Well, condensation is when it starts to turn from a gas into a liquid. Okay, so it's going to start to condense right here. That's our condensation point. For our condensation point and our boiling point, notice they are at the same temperature. So at the same temperature, liquid can turn into a gas can turn into a liquid. It just depends on the way energy is flowing. So in an exothermic reaction, if energy is leaving, gas is going to turn into a liquid. But if energy is entering it, if it's endothermic, the liquid is going to turn into a gas. For our second example, we have a cooling curve that we're going to take a look at. So it says, at what letter does the liquid phase begin to decrease in temperature? Okay, so let's first just recognize each of our different states. We have gas up here because gas has the highest temperature, liquid down here, and solid is going to be the coldest at the very bottom. So all you're really going to notice is our cooling curve is pretty much the same as our heating curve, except for that it's flipped. It's just flipped. So at what letter does our liquid phase begin to decrease in temperature? Okay, so it's going to be at this point right here. Okay, because at that point, our liquid phase starts to decrease in temperature, starts to go down this slope. Okay, and temperature's on the left-hand side. That shows us where, whenever it's going up and down, there's a decrease in temperature. Where does our kinetic energy decrease? Okay, so our delta KE means there's a change in kinetic energy. So we have to recognize whenever there's a change in kinetic energy. So whenever there's a change in temperature, there's a change in kinetic energy. So we're going to have a change in kinetic energy right here, then down here. So whenever there's a change in temperature, there's also a change in kinetic energy. What is the melting point? So the melting point is going to be whenever our solid turns into a liquid. So at what temperature does our solid turn into a liquid? Okay, that's going to be right here. So if heat was entering the system, if it was going in this direction, if heat was entering, right, it would start melting right at this point, or about 90 degrees Celsius. Okay, because that's where solid turns into a liquid, melting. It's our MP. And at what point is the substance 100% liquid at 150 degrees Celsius? So at what point on this line, okay, is it 100% liquid? Okay, well, it's 100% liquid right at this point, right here. And the reason why is because it's going from a liquid, or from a gas to a liquid if it's going in this direction. Okay, and once it gets to the end of that, it's all 100% liquid. In this, it's a mix between gas and liquid. Okay, so for there, it's like a mix between it until it gets to the end. Oops. All right, so those are your examples. If you guys have any questions, please let me know.